Assalamualaikum. The next topic is two variable regression, interval estimation and hypothesis testing. It's my lecture number 6. Interval estimation, some basic ideas. Interval estimation, interval around the point estimated within 2 or 3 standard error. On either sides of the point estimated 95% probability of the true parameters value. This is the interval estimation. Random interval, the two position number gamma and alpha between lie 0 and 1 such that the probability that is random variable. The third number is confidence interval. Beta 2 had minus gamma and beta 2 had plus gamma. Contain that true beta 2 is alpha is known as the confidence interval. Confidence coefficient 1 minus alpha is known as the confidence interval coefficient. Level of significance, alpha 0 is less than alpha and less than 1 is known as the level of significance. The endpoint of the confidence intervals are known as the confidence limit. Aspects of the interval estimation. The following aspects of the interval estimation is: number 1, the probability of beta 2 lying between the two limits is minus 1 alpha. Beta 2 are unknown and is assumed to the fixed number. Second point is the interval is a random variable. It will vary from one sample to the next because it is based on beta 2. The confidence interval is random. The probability statement attached to should understood in the long run sense. The interval is a random so long beta 2 head is not known. Hypothesis testing, the confidence interval approach. Two-side or two-tail test. The two-side and two-tail test to establish the confidence interval approach. Once again, we refer to the wages education. For example, from the regression result given the equation, we know that the slope coefficient is 0.7240. Suppose we postulated that the H0 is beta 2 is equals to 0 and H1 is alternative, beta 2 is not equals to 0. That is, the true slope coefficient is 0.5 under the null hypothesis but less than and greater than 0.5 under the alternative hypothesis. The null hypothesis is a simple hypothesis. You see the diagram, and the vertical axis the beta 2 head minus d alpha over b2 and the standard error of beta 2, and second line is beta 2 plus, and that is the negative, and other is the positive value of beta 2 and standard error of beta 2 head. Value of beta 2 lying in the intervals are the possible under H0 100 1 minus alpha percent confidence. Do not reject H0 beta 2 lie in this region. Next topic is one-sided or one-tail test. Sometimes we have a strong or purely theoretical expectation based on some previous empirical work that the alternative hypothesis is one-sided and unidirectional other than the two-sided. As they discussed, thus of our wages education example, one could postulate that H0 is beta 2 is less than 0.5 and beta 1 is H1 beta 2 is greater than 0.5. Perhaps the economic theory or the pure empirical work suggests that the slope is greater than 0.5, although the procedure to test the hypothesis can be easily derived. The actual mechanics are better explained in terms of the test of hypothesis approach discussed. Next, one-tail test is greater to alternative and less than alternative, but the two-tail test is equal to and not equals to the hypothesis testing work. Hypothesis testing, the test of significance approaches. Testing the significance of regression coefficient, the t-test. As our illustration recall, then under the normality assumption, the variable t is equals to beta 2 head minus beta 2 divided by the standard error beta 2 head. Follow the t distribution with n minus 2 degree of freedom. If the value of the true beta 2 is specified under the null hypothesis, the t-value of equation can really be computed from the available sample. Therefore, it can be served the t-test. You see the equation. Rearranging the equation, which gives the interval in which the beta 2 will fall with 1 minus alpha probability, given that beta 2 is equals to the beta 2 static. Language of hypothesis tells the 101 minus alpha percentage the confidence interval established. The equation is known as the regions of expectance and regions of acceptance and regions of the rejections. Region of acceptance is null hypothesis and the rejection is the critical value is null alternative hypothesis. It is called the critical value. In practice, there is no need to estimate explicitly. One can compute the t-value in the middle of the between the critical t-value or outside them. For example, the t is equal to 0.7240 minus 0.5 divided by 0.0700. So answer is the 3.2. Which is clear lie to critical region is this diagram. You see this the 0.5 is mid and the 0.6 is greater than to 0.5 and less than to 0.3. Critical region of 2.5 and the critical region of 2.5, but the beta head scale is equal to the 0.724. For it is the symmetrical value is and the H naught we reject. And you see this the type of hypothesis, H naught the null hypothesis, H1 the alternative hypothesis, and decisions rules the H reject H naught या H1. Two tail test, right tail and left tail. Two tail test and beta 2 is equals to beta 2 and 2 right tail test and beta 2 greater than beta 2 and the beta 2 less than the beta 2 static. Alternative में less than equals not equals to. Testing the significance of the sigma scale in the correct test. Another illustration of the test of significance methodology consider the following variable. Chi-square is equals to n minus 2 the sigma square head divided by sigma square, which had the chi-square distribution the n minus 2 the degree of freedom. For example, sigma square static is 0.8937 degree of freedom 11 to be reject and equals to 0.7 and not equals to 0.7 and t statistics for H naught the substitute of appropriate to be found the assume 5% interval the critical value of chi-square value. You see this the null hypothesis and the alternative hypothesis in the critical region and this equation. So the formulas of the critical region of H naught and greater and less than the sigma scale and sigma naught. Hypothesis testing the some practical aspects. The meaning of expecting or rejecting a hypothesis and the zero null hypothesis and two thumbs up rule. One of the bases of the test of significance says that the t-test we decide accept. The null hypothesis, the sample evidence, we have no reasons to reject it. A null hypothesis that is commonly tested is empirical work is H naught is equals to beta 2 is equals to 0. The slope coefficient is 0 adapting to the 2t rule of thumb of significance. See this the H naught is equals to 0 and H naught beta 2 is equals to 0 and not equals to 0. The hypothesis is two-tail test. Forming the null and alternative hypothesis and choosing alpha the level of significance. Null and alternative hypothesis testing the significance statistical significance should not longer may be the mystery. A type 1 error the probability of rejecting the true hypothesis. A type 2 error the probability of accepting the false hypothesis. Type 1 test error probability reject, and the error 2 is accept the false hypothesis. The p-value is defined as the lower significance level at which is the null hypothesis can be rejected. And the p-value obtained, t-value is 3.2 is greater than about 0.00001. That is extremely well. Regression analysis and analysis of variance. You said in this the we study the regression analysis from the point of view the analysis variance and introduction the reader's elimination and complementary of the looking statistical inference problem in chapter 3 lecture number 4. You see this the summation yi square is equal to summation yi hat ka square plus summation ui is equals to beta 2 hat summation xi ka square plus summation ui ka square is equals to, you see this this equation is repeated to the lecture number 4. TSS is equals to the ESS plus RSS, which is decompose the total sum of square is component of the explanatory sum of square and the residual sum of square is known as the analysis of variance. And the degree of freedom is n minus 2 is always. Sources of variation SS and degree of freedom in MSS, sum of squares and the master scale. Due to regression ESS and due to residual RSS, you see this is flow chart and see this F is equals to MSS of ESS is equals to divided by the MSS of RSS. And this equation, you see this beta 2 had summation xi ka square divided by summation ui ka square divided by n minus 2 is equals to the beta 2 had the square the summation xi square divided by the sigma square. This is the value of f. F is called ANOVA table. If we assume that the disturbance ui are normally distributed, which we do under the classical linear regression model, and if the null hypothesis is beta 2 is equals to 0 and the f variables of follow the f distribution with the 1 degree of freedom and the n minus 2 degree of freedom, the general properties of the f distributions are discussed. What use can be made the preceding F ratio? For this, you see this equation at the shown. E expected beta 2 square summation x I square is equals to sigma square plus beta 2 x square summation x square is equals to sigma square. Reporting the result of regression analysis, you see this example. हमें यू सी दिस एग्जांपल हमें यहाँ सब कुछ दिया हुआ है हमारे वाई एम सी स्टैंडर्ड एरर की एफ की डिग्री ऑफ फ्रीडम 11 है आर स्केयर 0.9065 है. हम देख सकते हैं कि हमने यहाँ पे सबसे ज़्यादा पी वैल्यू पर फोकस किया है जिसमें हमें इसमें वैल्यू बताई गई है डी के साथ. अगर हमारी डी की वैल्यू हमारी 0. नेगेटिव में है तो हमारा पी इज ग्रेटर देन 0.001. सो द इस प्रैक्टिकली इज 0 कहलाएगा जहाँ पर 10.3428 इज ग्रेटर देन द 0.00009. Normally test. We will consider 3 tests: histogram of residual, normal probability plot, and Jocular histogram of residual. A histogram of residual is a sample regression, a simple graphic device that is used to learn something about the shape of probability density function of the random variable. Normality probability plot, a comparatively simple graphic device to study the shape of the probability density function of a random variable, is the normal probability plot. Jocular test of normality. The GB test of normality is an asymptotic large sample test. You see this formula. Overall residual uses the test. Thanks for watching this video. I hope you understand this video.